This is exercise 1E.1. There's actually two versions of this because it's quite a big piece of work. So in this one we're going to look at how to find the determinant and the inverse of a 3x3 matrix, and then we'll practice it in class, and obviously then extend it to try to get you good at it in the second lesson as well. So just for a brief reminder, if we asked to find the determinant of, I'm going to make up a matrix like of 3, 1, or 3, 2 it would seem now, 1, 5. Now you should remember the formula is AD minus BC. AD, B, C, D. So what we times a 3 by the 5, which is 15, and we take away 1 by 2, which is 2, so that's 13. And if we want to find the inverse of this, so 3, 2, 1, 5, you might remember the notation, put or minus 1. If you want to find the inverse, the very first thing you do is find the determinant, and then you do 1/13 of, in this case it was 13, so that's why effectively you divide all the numbers by 13. And if you recall, you switch these two around. The 3 and the 5 become 5 and 3, the other way around. But the other diagonal, you switch the sign, so this is minus 2 and minus 1. And that's the determinant and inverse of a 2x2 matrix. Another little starter, we did a couple of these last time if you recall. Now I want to move this onto the other side. This is a bit of algebra really. And I talked last time about the fact that I've got to multiply it by its inverse in order to move it over. And you have to do the same thing to both sides. And you'll notice I have to do it here on the left, because that's where effectively the matrix I'm trying to move is. So I need to find the inverse of 4172. And I times him by 4172, x. And I do it to one side, I do it to both sides. And times by the 3 minus 4, 0.8 is already over there. And of course the whole point about doing this is they cancel out. It becomes the identity x equals. Now what is the this? I need to first of all work out its determinant. So I think it's 8 minus 7, which is 1. That's lucky because I'm going to divide by 1, which of course doesn't change anything. But I do have to switch the round still and change the sign still. It wasn't too bad, was it? You could do all this on a calculator because there's no x's involved in a's and b's and k's. So when there's letters, you've got to care a bit more. A 2 by 2 by 2 by 2 will give us a 2 by 2. I'm looking for 4 numbers. That's 6 minus 8. I reckon that is 0. No, minus 16. Nearly made a mistake. Minus 21. And my last one is minus 7 times minus 4 is 28. 4 8s are 32. I reckon that makes 60 between them. So I think that's the answer. Now I want you to try to work out what y is. It's very similar, apart from this time I think you have to do a right multiply by the inverse on both sides. So these are my solutions. That looks right. You've got the answer. Can you try and make sure you get that answer? So anyway, so new idea, we're going to introduce something called cofactors of a 3x3 matrix. And you're sometimes asked to find them, sometimes you're not. Perhaps sometimes I might even mention them and they expect you to do it. But the cofactors is what I'm going to do now. It says find the cofactors of these. Now cofactors are labelled. You end up with a matrix of cofactors, and sometimes there's an MC or something like this. And when you do it, I'm going to call the first one A1, then B1, and then C1. You get an A2, a B2, and a C2, and an A3, B3, C3. So just bear that in mind, that we label the different things. There's 9 of them obviously in the 3x3. And I've said here, remember these signs, plus, minus, minus. These matter. They matter when we're finding these A1, B1, and C1 and stuff. Now, I'm going to show you first of all the A1 here. Now, notice how I've got these numbers. I've got minus 2, 1, 0. And it's actually these numbers here. Because I want this one, I ignore these, and I just pick up these numbers here. And I just find the determinant of these. Minus 2 times 0 is 0. Minus 1 times 1, as we would normally do, is minus 1. So effectively I now know my A1. Now unfortunately I'm just going to now delete some stuff up here. That's the advantage of a board, I suppose, like this on a board rather. Now, what I now have to do is try to find what's called B1. So I shall do B1, and because I want this one now, I ignore those, and I ignore these, and my numbers now are these four numbers. And so I find the determinant of these four numbers. And you'll notice it's 0, 1, minus 3, 0. But interesting, there's a minus in front of it. And that's because of this little thing here. Remember these signs. It always goes plus, minus, plus. Always, always, always. So now I'm finding B1. It's 0 times 0 minus 1 times minus 3, which is plus 3. But because of that minus, I get minus 3. So I now know B1. And now I find C1. So again, I'm going to go and rub it all out my horrible annotations. And I'm going to try to find C. Come on, pen back. I'll try and find C1. Now, okay, C1 is there. So I ignore those, and you can see these are my numbers. And I find the determinant of those numbers, 0, minus 2, minus 3, 1. I reckon it's minus 6. And notice, because of this is a plus, and I'm finding C1, therefore it's no minus in front. The answer is minus 6. So I've done 3 of them. I'm now going to do some more. Again, I'll rub out all of that lot. And which one am I after? I'm after now A2. Now A2 is here. And notice therefore I ignore those. I've got 5, 2, 1, 0. And 5, 2, 1, 0. But notice the second row starts with a minus. So therefore I need a minus. I find these equals to 2. I now, again, I get bored of doing all this in a bit, but for now I'm keen. I now switch to B2. B2 is there, so again I ignore them, and I've got these numbers. And if I do the determinant of those, it's 6. It's a plus in the middle, so therefore it's plus 6. I'm now going on to this one here, so you can see I ignore that row, I ignore this row. I reckon it's 4, 5, minus 3, 1. 4, 5, minus 3, 1. But notice the minus, because for that position it's a minus. And I keep doing this. Next one is I'm looking in this position. So ignore those. I reckon it's 5, 2, 2, 1. 5, 2, oh, it's a minus underneath there. There you go. Didn't even see it. But again, notice please, it's a plus position, so therefore it's a plus. I reckon 9. And you keep doing this for the last one. There's the B3 when you look there and ignore 4, 2, 1, and 0, 1. It's a minus because it says it's a minus. And the last one is C3, and I reckon C3 is there, so I ignore them. 4, 5, 0, 2. Oh, it's a minus 2 again, still can't see the minus. But again, it's a plus at the front, so therefore I do it. Now, they are called the cofactors. And they're painful because you've got lots and lots of things to find out. But notice, having done that, the cofactors of M, I can now write it as this, as a matrix if I wanted to. Now, the next thing I'm going to find is the determinant of a 3 by 3 matrix. The determinant of a 3 by 3 matrix is going to be defined as this. Oh, have I even done it? Yes, I have there. So that is my formula. So what I want you to do then, sorry about that, what I want you to do is to copy down this formula into your book. And it's basically another one of those. And hopefully your notes are such that you've got the A1, B1 and stuff defined properly, and then we can use it. Now I've got a new matrix for you here, and it says find the determinant. So look, to find the determinant, it's going to be 3 times by this determinant. So it's going to be 3 times by determinant of minus 2, minus 1, 3, 0. Now one way of doing, remember I said it's plus, minus, plus across the top. Now, if I've already found, well, this is A1, you see. If I've already found B1, I'd now write plus, and I'd do it. But I haven't found B1 yet, and I've got to insert a minus. So just be a little bit careful. It's plus a minus, and it's 2 times by. And what is it times by? Well, I've got that 2, so it's 1 minus 1, 2, 0. 1 minus 1, 2, 0. Now, this minus really is attached to there. It might be better put there, actually. Let's put it there. But what I was, it might be that you can see what I've kind of done. If I haven't found a B1 already, it might be better just writing minus here and just doing plus, minus, plus here. and just using the the determinant. If you've already found B1, then don't put a 2 in. That's what I'm trying to get at here. Plus, what's my last number? It's 5 times by, I reckon it's 1 minus 2, 2, 3. So if I do this, it's 3 times by, that's 0, minus 3, minus 3, I think it's 3 times 3, plus, I've got here 2 times by, now this is 1 times 0 is 0, minus a minus 2 is plus 2, and it's minus as well, so I think it's 2 times minus 2, plus 5 times, and I reckon that is, if I do that, 7. So that gives me 9 minus 4 plus 35, which I actually reckon is 40. So it says, find the first 3 cofactors. Did we get those right? 3, yes. Minus 2, yes. 7, yes. Chuck it into our top row to find the determinant. 40, yes. So hopefully you've seen how to do that, and you'd be able to repeat that. Now the inverse of the 3 by 3 matrix, we have to do a painful process. Now if you remember, our matrix was 3, 2, 5, 1 minus 2, 1, 2, 3, 0. And to be honest, I'm not going to go through all those again. You've got to find all these different cofactors. All the A's, all the B's, all the C's. I'll just pick one maybe. No, I'll just if you're not sure, ask. And otherwise I think I'll run out of time. So anyway, that's the all the cofactors. And once you've got that, you put it into the matrix of cofactors. Could have done it on the very first example we did, but here you'll notice the ones I found just now when I was finding the determinant, let's look at these, were 3 minus 2, 7. So here I've got 3 minus 2, 7. And then, not surprisingly, 15 minus 10 minus 5, 8, 8, minus 8. So that, I've just put them in the right places. But now I have to transpose the matrix. So having gone from this matrix, 3 minus 2, 7. So let's just write that down. 3 minus 2, 7. What was it? What was next? It was 15 minus 10 minus 5. 15 minus 10 minus 5. 8, 8 minus 8. And notice what I do with that is I transpose it. And when I transpose it, if you remember, the diagonal stays the same. 3 minus 10 and minus 8. But the ones that go across now go down. Minus 2, 7. Then it goes 15. And the ones that go down go across, so you can kind of go 15 and 8. And it won't surprise you that that 8 goes there and that minus 5 goes there. I think I've done that right. That is the transposed matrix. And they look as if they're right. Good. Now we have to divide by the determinant. Dividing by the determinant is important. We found the determinant was 40, so you write it as a 40th of all of that. And that is the inverse matrix. I think you'd probably agree there's quite a lot to look at there. So in class we'll do lots of practice of that. And the mere fact I've got 2 lessons on this implies that it takes a long time to get your head around it. It's more than doable, but it's so easy to make daft mistakes. And you'll notice when I had the opportunity just now of finding these, I kind of said, oh, I can't be bothered because it's painful. You will need to obviously bother, because without those determinants, and there was the 3 before it plus these 6, you need all 9 to get the cofactors. Then you get the matrix of cofactors. Once you've got the matrix of cofactors, you transpose it. Once you've transposed it, you divide by the determinant to eventually get your answer, tick. So we'll practice this in class, exercise 1E, and as I say, it's 2 lessons worth to finish it all off. So, okay, thank you.